This is example problem 4. And again, it's a vector at an angle, and it's a vector at a slope. And so properly dealing with those, we're going to add these two vectors to get a resultant. Our vector in polar form, we're given 40 degrees from the negative y-axis. And so the angle, the correct angle here is 90 plus 40, which is 130 degrees, and that's negative. So I enter him as 200 at negative 130. Or you could go 180 plus 50, and so you can enter it as a positive 230 as well. And once you enter that, it'll display in your calculator in this way. If you're using a vanilla scientific calculator, then the x component is 200 sine 40, which is negative, and the y component is 200 cosine 40, which is also negative. So negative, negative. For this guy, I'm giving him his direction as a slope. And so I take 4 over 7. This is not a perfect square. So 4 squared is 16. 7 squared is 49. 16 plus 49 is 65. So the hypotenuse is the square root of 65. If I divide all three sides by this guy, I get a hypotenuse of 1. This side is 4 over square root of 65. This side is 7 over the square root of 65. Because this is in quadrant 2, the y component is negative, the x component is positive. And so I get a positive 7 over square root of 65 is the x component of the unit vector. And then I have a minus 4 over square root of 65 is the y component of the unit vector. Or I can just go into my calculator, enter, and I'm just going to go to the unit vector, click the catalog, and I'll go U, the unit vector function, enter, square bracket, and then I've got 7, comma, minus 4, enter. And I get 0.8682 and negative 0.4961. Isn't this unit vector function super easy? It's just super easy. It's a great way of dealing with these slopes. This is my unit vector. I take this guy times 300. And I get 260.5 and minus 148.8 are my components of F1. So I'm going to take this guy and add control square bracket, this guy, which is 200, comma, angle symbol, minus 130, enter. And if I add these two guys, I get my resultant is 131.9 and negative 302. If I want to see that in polar form, I go to my catalog, I go to P, I scroll down to polar, and I get 329.6 at negative 66.4 degrees. If you're using a vanilla calculator, then you can use the norm function or the square root of the sum of the squares to get the magnitude, which is 329.6. And then to get the angle, I can draw this picture of the resultant down here. The x component is 131.9. The y component is 302. And so theta is the inverse tangent of 302 divided by 131.9. I get 66.4 degrees. And since that's down from the positive x, it's technically a negative angle. And so that's my resultant. So 4 different example problems, each with a vector at a slope, each with a vector at an angle. These are like doing our exercises. And so we're just learning the fundamental skills of how to do this in our calculator. how to add them graphically, how to deal with slopes, how to deal with polar form, how to use the norm function, how to use the polar function. And so just skills that you need to be able to do. You're starting to see why I really strongly recommend, a TI-89 or an nSpire or some similar calculator that lets you enter these vectors exactly how they're given. It really helps.